In this video, we will know about the chapter 2 of the class 10th mathematics, that is polynomial. That is polynomial, chapter 2 of the class 10 mathematics. In this chapter, we will know about the zeros of polynomial, relationship with coefficients, and the division algorithm. The next slide. By the end of the chapter, we will know about the identifying the polynomials, which type of polynomial is it, and the relationship with the coefficient, and the division algorithm, and zeros of polynomial, how to find a zero of a polynomial, and the form of a polynomial, how to form a quadratic polynomial from the given zeros, and the graphical meaning. At first we will know about what is polynomial, that is the definition and its degree, and after knowing that what is polynomial, we will discuss about the zero and the linear and the quadratic. After that, sum and product of the zeros and how it related to the coefficient of the quadratic equations. And fourth one is the forming polynomials. If the zeros are given, then how to form a polynomials. And the second last one is the division algorithm, that is quotient and remainder, and sixth one is the application and graphs and problems. A polynomial, first we know about the what is polynomial. A polynomial is a one variable x is an algebraic expression in the form, that is px an x to the power n plus a to the power n minus 1 x to the power n minus 1 plus a1 x plus a naught, where an minus 1 are the real numbers and a naught is not equal to 0. This condition should be fulfilled for the polynomial. What is coefficient? Each ai in called a coefficient of the polynomial. Here an minus 1, a1 are the coefficient of the polynomial. Degree, the highest power of the x with non-zero coefficient is called the degree. Highest power of x is with non-zero coefficient is called its degree. Constant term, a naught is a constant term of the polynomial. Here a naught is the constant term of the polynomial. Next, classification by degree. If the degree is okay, the ink is not shown, so wait. Here degree is 0. Degree is 0, that means it is a constant. Let's example px is equal to 7. Here is no variable term. If degree is 1, then it is a linear polynomial. Example px is equal to 2x plus 3. It have only one zero. Degree 2, that means it is called quadratic equation, and the examples is x square minus 5x plus 6. At most maximum 2 zeros are available. If the degree is 3, that is known as cubic, and its example is x cube minus 1. At most ज़्यादा से ज़्यादा 3 zeros are available for this. If degree is 4, then by quadratic px is equal to x to the power 4 minus 16. At most maximum number of zeros is 4. If n degree is equal to n, then degree n and form is px is equal to a n x to the power n plus maximum number of zeros are n. Next slide. Zeros of a polynomial. Zeros of a polynomial. A real number alpha is the zero of the polynomial if pa is equal to 0. That means if any number is the zero of a polynomial, after the putting the value in the polynomial, it gives the value is equal to 0, then it is known as the zero of the polynomial. Geometrically, 0 are the x coordinate of the points where the graph y is equal to px intersect the x-axis. Generally, zeros are the x coordinates where the graph meets at x-axis. If the equation is linear, then it forms px is equal to ax plus b, then 0 will be x is equal to minus b by a, exactly 1 0. If the equation is quadratic, if the polynomial is quadratic polynomial or maybe it quadratic equations, then its form is ax square plus bx plus c. Then the roots of ax square plus bx plus c are the zeros. The maximum number of zeros are available for 2. If cubic equations that px is equal to ax cube plus bx square plus cx plus d is equal to 0, maximum number of zeros available is 3. May have 1 or 2 or 3 real zeros. Finding 0. There are some examples. After seeing that, we learn how to find zeros of a polynomial. Set px is equal to 0. Here the px is given 3x minus 6. 3x minus 6 is equal to 0, and after 3x minus 6 is equal to 0, after equating both sides adding plus 6, then the equation gives rise to 3x is equal to 6. After dividing by equation 3, x is equal to 2. Here the 0 is equal to 2. That means it is a linear polynomial, hence number of zeros is 1. Then the second one is the quadratic equation, quadratic polynomial. Here the number of zeros, after finding it, there are 2 zeros which are available. So here the equation is x square minus 5x plus 6. After the prime factorization, after solving the equation by factorization methods, we get x minus 2, x minus 3 is equal to 6. After equating with 0, x is equal to 2 and x equal to 3 are the breaking points. These are also known as the zeros. Next one. For a quadratic equation, px is equal to ax square plus bx plus c. A is not equal to 0. There are some relationship between the sum of the zeros and the product of the zeros with the coefficient of the quadratic polynomial. In this we will know about how the sum of the zeros which relate with the coefficient of the different polynomials. So sum of the zero is related to the minus b by a, that is the coefficient of x with negative sign divided by coefficient of x square. Here the product of 0, alpha and beta. First we will know about the alpha and beta are the two roots of the quadratic polynomial, and the product of the alpha and beta is equal to c by a. C by a, that means the product of the roots. These are the relationship between the sum of the roots with the coefficients and the product of the roots with the coefficients. Let's some check and a product check. Let's say an example of a x square minus 5x plus c. It is an quadratic equation. Generally it gives power 2, hence it is a quadratic equation, quadratic polynomial. Here alpha is equal to 2 and beta is equal to 3. After calculating that, first the coefficient of x square is equal to 1, coefficient of x is equal to minus 5, and the constant term is c. So we know that the alpha sum of the roots, here the given 2 and 3 is equal to 5. By the formula minus b by a, minus b, equate the value with the minus b is equal to minus 5 by 1 is equal to 5. Both are equal, hence the relation is correct. After the product check, alpha into beta is equal to 2 into 3 is equal to 6, and it also equals to the c divided by a. After putting the value of c and a, it gives is equal to 6. Then alpha into beta is also equals to c by a. That means the relationship is correct. Forming a quadratic equation. If the sum of the roots and the product of the roots are given then how we form a quadratic polynomial? If alpha and beta are the zeros, then the polynomial is, here px is equal to the k bracket x square minus alpha plus beta into x plus alpha into beta, where k is not equal to 0 for any constant. If example, let's an example 3 and minus 2. Sum is 3 plus minus 2 is equal to 1. Product is 3 into minus 2 is equal to minus 6. how to form a quadratic equation. Then x square minus 1, that is the sum of the zeros, 1 into x minus with negative sign, plus product of the roots, that is minus 6 plus product of the roots. Here the equation form. This is the maximum power is 2, hence it is a quadratic equation. From the quadratic equations, there are the some examples. After 0 is given 4 and minus 1, sum is 3 and product is minus 4, then the equation becomes x square minus 3x minus 4. If the zeros are given root 2 and minus root 2, then the sum is 0 and the product is minus 2, then the equation becomes x square minus 2. If the zeros is given 1 by 2 and 1 by 3, then sum is 5 by 6 and product is 1 by 6, then the equation becomes 6x square minus 5x plus 1. If the zeros is given as minus 3 and minus 5, then the sum is minus 8 and the product is 15, then the quadratic equation or quadratic polynomial becomes x square plus 8x plus 15. Division algorithm. In this slide we will know about the division algorithm for the polynomials. If px and gx are the two polynomials with gx not equal to 0, px and gx are the two polynomials, then we can find polynomials qx and rx such that px is equal to gx into qx plus rx, whereas rx is equal to 0, but the degree of rx is less than the degree of gx. Degree of rx is less than the degree of gx. Dividend. Px is the polynomial being divided. Px is the polynomial being divided. Divisor gx, the polynomial we divide by, and the quotient qx, the result of the division, and the remainder rx, the leftover of the lower degree. Suppose an cubic equation, cubic polynomial, and it is given as a px is equal to x cube minus 3x square plus 5x minus 3, and gx is x square minus 2. So the first step is whether it is check the power, or that is degree of gx is always lower than the px. Here it is always lower, here power is 3 and here is 2. After dividing, here power is x3 and here power is x square, then which term is multiplied to get x cube? So multiplied by x, that is x. So multiply x with x square minus 2, that gives x square minus 2x, and after dividing all these, the remainder is 7x minus 9 and the quotient is x minus 3. After you divide in this format, x square minus 2 here and x cube minus 3x square plus 5x minus 3, you gives rise as a quotient as a x minus 3 and remainder 7x minus 9 after dividing. Verify px as a gx into qx plus rx. Here x square minus 2 and x square minus 3 both are multiplied, because gx is x square minus 2 and qx is x minus 3. Both are multiplied successfully and gives x square minus x cube minus 3x square minus 2x plus 6 plus 7x minus. After adding all these, the final equation is equal to the px. That means that it is a correct relationship. Remainder theorem. If px is divided by x minus a, if the any polynomial px is divided by x minus a, then the remainder is pa. Then the remainder is pa. If pa is equal to 0, then x minus a is a factor of px. That is known as factor theorem. If pa is equal to 0, after putting x equal to a, the polynomial gives it to 0, then it will called as the x minus a is a factor of px. Zeros on the graph. If the polynomial is linear, then the straight line crossing x-axis at one point, that means it has only one zero. Quadratic and open up, that is it forms always parabola may crosses x-axis at 0, 1 or 2 points. Quadratic opens down, that is inverted parabola, same possibilities for 0. Cubic S-shaped curves and crosses x-axis at least once odd degree. Just remember the things which we studied earlier, that is the sum of the zeros. Alpha plus beta is equal to minus b by a, and the product of the zeros is equal to c by a. In that these are the relationship with the coefficient of the polynomial. Here the quadratic form zones, how to form a quadratic from a sum of the roots and the product of the roots. The equation is k into x square minus alpha plus beta plus alpha into beta. Division algorithm, px is equal to gx into qx plus rx. Remainder theorem, when divided by x minus a is pa. Factor theorem, x minus a is a factor if pa is equal to 0. After putting x is equal to a, the polynomial gives 0, then x minus a is a factor. Common mistakes to avoid, these are the mistakes you generally avoid: forgetting the constant k, sign error in sum and the degree of the remainder, and assuming two zeros always, confusing factor and remainder. These are the mistakes always to avoid. These are the some questions you can use at your home for better understanding about the quadratic polynomial and the polynomials. You can find the zeros of the equations, px and qx are given. If the zeros are given, then find the relation between a, b and c. Form a quadratic polynomial where the zeros are given. Divide x square plus 3x square minus x minus 3 and gx is given. Then how to write the quotient and remainder using remainder theorem. How to solve when divided by x minus 2 with it is a dividend, it is divided by x minus 2, then what is the remainder and the quotient. Verify 3 and 1 are the zeros. In the last question, 3 and 1 minus 1 are the zeros, and how to check sum and product relation. And lastly, thank you for joining us in this lecture. That is the polynomial chapter 2, master of the zeros and own the coefficient and apply the algorithm. Practice daily, revise formulas and solve NCERT exercise problems daily and regular. Thank you for joining us.